Hey everyone, my name is Courtney and this is my Engineering 305 video final. In this video I'm just going to be discussing a bunch of different things that I've learned throughout the course. A lot of the things that I'm going to be talking about I have already done in other presentation videos for this class, so rather than go through all the demonstrations and jump again, I might just reference you to that video, and I have the links included in each slide. So the first tool I'm going to talk about is Graph Builder. Is used to create and modify all kinds of graphs. Some of these graphs include line of fit, contour, line, bar, area, box plot, histogram, and pie, and there's a bunch more. And it's a really useful tool because it's very interactive, so you can change the variables and the graphs and kind of just keep messing with it until it displays the data in the way that you're looking for. But it can be used for all sorts of data analysis. For example, if you have data from multiple product lines and their profit data, you could analyze how the profitability is different between product and line, or different between product lines. And that's kind of what we're going to do here. This is the result, but we're looking at the jump data product. So first you would open your data, then you'd open the graph builder, and you would put the quarter down in the X, and then you would put revenue, product cost, and profit into the Y zone. Then you would change the plot to be a line plot, and finally you would drag and drop the product line into the wrap zone, which is usually up here in the graph builder, and doing all that will produce this final plot for you. And looking at it, you can see that credit products, deposit products, and revolving credit products all have produce the most revenue, but however the profits of all of these product lines are very similar. And again, this is just one example of what you can do with Graph Builder. So the next thing I'm going to be talking about is the chi-square test. You can look at our presentation 1 video to get more details and see the data, but these are the actual results. The chi-square is really useful in counting data. The underlying distribution is Poisson. The data needs to be discrete. But these contingency tables and mosaic plots are probably one of the most useful ways to display your chi-square tests. So for this example, we were looking to see if a person's weight changed based on what they drank, and just looking at this mosaic plot, it's very easy to see visually that the people who did not drink any tea had the most weight gain, and the people who drank green tea lost the most weight. So basically this tool would be really useful in any business situation where you're basically trying to check to see if one variable X is related to or independent of another variable Y. So for example, you could use this to see if certain types of products sell better in certain geographic locations than others, and that's just one example. So next topic is the DOE, or design of experiments. We talked about this in presentation number 5, so you can click on or go to the link down here to see more detail and to see the jump demonstration. But design of experiments allow you to understand the effects of different variables on other variables. So we use the popcorn DOE results data to look at, and you can see this is how we set it up. But firstly, to generate the design of experiments in JUMP, you need to have your factors, responses, models, and then do the runs. So doing the DOE in JUMP will generate the different experiment combinations that you need to do, and then you actually physically run them, enter in your results, and then you would do the fit model, which is this table here. And one of the most useful things that I found in the results window of doing the fit model is the prediction profiler here. You can click on this arrow to maximize, and then click maximize desirability to get the response value closest to the specified target. And then it basically just gives you the combination that will give you the best results. So here we'll be talking about RSM, or response surface method, which is kind of a variation on the traditional DOE. It allows you to estimate interactions and even quadratic effects to give an idea of the shape of the response surface being investigated. And you can identify a point where a maximum or a minimum value of the response occurs. So These are results looking at tire bounce data in jump. So they're trying to find out which combination of silica, sulfur, and silane produce the optimal stretch in a tire. So you would need to use all of these data sets in jump because they ran the experiments for you. So you would kind of just plug them in. But basically you would go to the DOE response surface design tool and you would load the jump responses and factors for the tire data. And then once you fill out the rest of the information in that tool, you would get a box Binkin design table. Then you would conduct the experiments that they suggest, and you would enter in the results into that table. Once all those results are entered in, you can then do the fit model like we discussed in the last slide, and you get all of these results here. So you can see it gives you all the different combinations from the experiments, and all of them are significant and you should look at more closely, except for the silica and silane and the silane and silane. Those are not significant, so you could probably ignore those factors. But then you can also do the prediction profiler again, and do maximize desirability to see which level settings are optimal, and this is the result that you would get. Next is control charts. We talked a lot about these in presentation 4, but here are some of the basics. There are many types of control charts in jump, but the main ones that we focused on in this class were the X bar and the R charts, or the mean and range charts. They're used for quality characteristics measured on a continuous scale. A typical analysis shows both the process mean and its variability with the mean chart and its corresponding R chart. So the jump data we looked at was coding, and here is the range chart, and here is the mean chart, and the characteristic of interest for this data was weight. You can see that it is a useful way to visually see the upper and lower control limits based around the mean and the range, so those two green lines. So looking at the data in this way can help you to see what processes may be out of control. And this is really useful in any quality control process where you're trying to make sure that you're within the limits of, the standards for your company or for a client that you may have. So another really useful quality control chart is the Pareto charts, and it's considered one of the 7 basic tools of quality control. We also discussed this in presentation 4, but it consists of both a line and a bar graph. So you can see a picture of that here. The line is a cumulative percentage, and the bar is the count descending, so it's getting smaller. The data that we used here is quality control and jump. It's a great tool to see where your trouble areas lie, such as in this graph. You can see that almost 50%, so if you follow this one here, you go over 50% of the defects are coming from this first column, which is size. So if you were trying to improve a process or improve like your product, you'd probably want to focus on that characteristic first, since it's causing you the most problem. So here's something that we haven't talked about in one of our previous videos, hypothesis testing. You can use hypothesis testing for means and jump using the z-test, t-test, pair t-test, and 2-sample t-test. But we're going to focus on the pair t-test in this video. So for pair t-test, you're using the same population twice to run experiments on them to see if the samples are statistically different. So in this case, we're looking at thermometer data, and we want to compare readings from a new eardrum probe thermometer to readings from a standard oral mercury thermometer and see if there's a statistical difference. So you would do that by just setting up a distribution and jump, looking at the difference in the thermometers, and then you would get this output right here to compare them. And then you would click on this red arrow and you would click test mean, and you put in your hypothesized value. So our null hypothesis is that there is no difference between the readings of the thermometers. And then you get this section to pop up, and you can see that's the 0 value. And then you look down at the p-values and you see that they are smaller than 0.05, so they're statistically significant, meaning that you can likely reject the null hypothesis and that there does appear to be a statistical difference in the readings of the thermometers. So this can be a really powerful tool in business, especially if you're trying to compare two different items or samples and you want to see if, maybe you're trying to decide if you should stop producing a product because the newer one's better. So you could look and see like the ratings of them and see which one's rated more highly to see which one you should continue to produce and which one you could stop producing, just as an example. So now we're going to talk about linear multiple regression. We talked about this in presentation number 2, but it can be used to model the relationship between two continuous variables. The data that we looked at was the big class data and jump, and the goal was to see if there's a correlation between height and weight of the students. So you would do this by setting or choosing a fit y by x in jump, and you can see both of them are continuous, so we're going to be looking at the bivariate or the linear model. Here's what the results actually are for this specific data, and then you can look at the R-square value and see that it's 0.5, so that's not close to 1 really at all. So it doesn't appear to be a strong correlation between height and weight, at least according to this data. This can be a really powerful tool in business because it can evaluate trends and estimate forecasting based on consumer behavior and characteristics. So that's going to be pretty useful for companies to use. So logistics multinomial regression was also discussed in presentation 2. It can be used to predict the probability of the occurrence of an event. So in this case, the goal is to predict the probability of being cured by penicillin based on the dosage. So the data was penicillin and jump. So to do this, you use the fit y by x, and then you put a categorical as your y and a continuous as your x. And as you can see, you get a logistics model, and here are the results that you get for this data. You can look at the p-values and you see that they are significant, so this suggests that the dosage does have an effect on survival. And the main thing to note about multinomial modeling is that it can include nominal data or categories, and the dependent variable should be measured at the nominal level, and the independent variables can be continuous, ordinal, or nominal. So logistics regression is a really powerful tool in making predictions, and it can also determine consumer behavior. But unlike linear regression models, which are used to predict a continuous outcome variable, logistics regression models are mostly used to predict a categorical outcome. So the final topic that I will be looking at in this video is mosaic interpretation. We kind of touched on this when I was talking about the chi-square test in the beginning of the video, and we also discussed it in presentation 3, but here's a little bit more about it. It can be used for visualizing data from 2 or more qualitative variables, and it helps in recognizing relationships between different variables. The data that we looked at here was Titanic passengers. It's very easy to set up and jump. So basically you would just do the fit y by x, and you would put this categorical survive data as your y and your categorical passenger class as your x. And you get this mosaic plot and this contingency table. Looking at the mosaic plot, this one's pretty easy to interpret. All the blue means that they did survive, the red means that they didn't, based on their class. So you can see that people in class 1 had a much higher survival rate than the people in class 3. And to get more specific numbers, you can come down to the contingency table, where you have didn't survive, survived, class 1, 2, 3, and this is kind of like a key for how to interpret the table. So this first row is your count, and it's the same for each class, the total percentage. Down here is your second row, column percentage is your third row, and row percentage. So you can see for class 1, you have 323 people total, and this is how many of that number did survive and didn't, and you can do that for each of the other classes. Then the total percentage of people, you can see that there were 24% of the people were in class 1, 21 were in class 2, and 54 were in class 3. Then the column percentage, so 15% in class 1 did not survive, 19% in class 2 didn't survive, and 65% in class 3 did not survive. And you can do that for the survived ones as well. And finally, you have the row percentage. So you can see that there's 38 people in class 1 that didn't, and 61 that did. 57 in class 2 did not, 42 did in class 2, and same thing for class 3. So that's all I have for you. Here are my references that I use for this video. I hope that by watching this you kind of have a better understanding of some of the statistical analysis that you can do using JUMP and how that might apply to a business case in the real world. So thanks for watching.